Greetings and welcome to my new calculus channel. My name is John Gabriel. That's me in the photograph, but that was many decades ago. In any case, I'm not here to talk about me, but to talk to you about a topic that I find it absolutely incredible that many math professors still don't understand. And in fact, most students of mathematics don't actually understand either. So let's begin. Now, look, when we begin with numbers, right, we have a number like this. What's happening is that we cannot talk in geometry about a certain distance, this blue distance, unless we compare it to another distance, okay? So if we had to write this blue line compared with the red line, it would be blue colon red line, right? Okay, as for example, if you represent it in algebra, you would say P colon Q or X colon Y. This combination here is a name. This blue and red is a name for this magnitude, okay? And in geometry, it doesn't matter how many different ratios you have. They're in proportion, but they're not equal unless both their antecedent parts and their consequent parts are equal, okay? So this ratio is in proportion to this ratio here, because this blue line is to this blue line as this red line is to this red line, okay? So they're in proportion. And of course, they're also going to be in proportion to these lines, okay? So this blue line is in proportion to this line, and this red line is in proportion to this line. And this is how we give the distances in geometry a name. The name would simply just be this with the and a colon in the middle, okay? So that would be a name. And any other representation like the one that you see down here would once again be a name for this distance, this blue distance, because the blue is the antecedent part and the red is called the consequent, okay? So we say they're in proportion. Now, in geometry, if we're looking at a right angle isosceles triangle, like this one over here, we can say that this blue ratio is not equal to the red ratio. They're in proportion, but they're not equal. Why? Because this blue line here that I'm highlighting is not equal to the broken dotted red line, okay? To the broken red line. So they're not equal, and neither is this length here equal to this length, which these are the consequents, right? 2, 3, and 2 are the consequents. So neither the antecedents, the 4.243 and the 2.828, nor the consequents are equal in geometry. But they are in proportion, okay? This is what this little symbol here means. It means it doesn't matter where you go, all the way here, there, etc. They're all in proportion. When are two ratios equal? Only if they're the same, okay? That's the only time that these ratios will be equal, is if they're the same, right? Otherwise, they're never equal, but they're in proportion. Now, in algebra, a totally different story happens, because in algebra, we look at ratios of numbers. So we give, for example, this length here a name in terms of a unit, in terms of some unit, and also this 3 a name in terms of the same unit. And then we refer to them in the way that we do on this side here as one number over another. So in algebra, all these fractions, which are ratios of numbers, which are ratios of numbers that are multiples of the unit, the chosen unit, whichever unit you choose. In algebra, it doesn't matter, because algebra deals only with the abstract unit. You see that? Algebra deals only with the abstract unit. So it doesn't matter wherever you are over here, okay? Algebra will only worry about the abstract unit, whose size is completely irrelevant, isn't it? Okay, so the conclusion. A ratio P colon Q is not the same object as the number P over Q, okay? And P over Q does not mean P divided by Q. It's the way we denote this number in algebra, okay? So in algebra, P over Q is a name. It's a name for a number, right? Just as P colon Q is a name for this antecedent, P. That's how we recognize or we know what we're talking about. So ratios are equal if and only if their aliquot parts are equal. What are their aliquot parts? The antecedent and the consequent. In geometry, 1 to 2 is not equal to 2 to 4, but they are in proportion. Now in algebra, 1/2 is equal to 2/4 because the abstract unit is used, okay, and its size is irrelevant. So 1/2 is equal to 2/4 is equal to 4/8, or any other fraction that would reduce to 1/2. So numbers, being abstract objects, have no physical units. And a number is a name given to a measure that describes a magnitude or size. I'm John Gabriel. This is a new calculus channel. Till next time, goodbye.